Another problem session. So today is the second problem solving, and it turns out to be a good problem. So again from JEE Advanced Paper 2. That's what we are solving these days. And I'm up to question number 7. Okay. This is actually a very trivial problem, and I would expect most people to get it. If you don't get this one, then I don't think. Yeah, it's pretty hard to do well on the test if you don't get this kind of problem. So there are these infinitely large thin plates. They have different amount of charges, and these are 5 regions. They also give the sigma 0 value, and they also keep it simple. Permittivity is just free space or vacuum. So this is all vacuum. And there's another configuration in which the end plates, their charges have cut into half, but the middle plates are remain the same. And so the question about these and this in these 4 parts. But before you really begin the question, you should know this very simple thing, that if you put an infinitely long plate and you put a plus sigma 0 is a coulomb per meter square. This is charge density on it. Then you expect electric field to be perpendicular and going in both directions, perpendicular to the plate. So these are perpendicular plates going in both directions. All the space is filled up. Electric field here, electric field here, and that value is sigma 0 over 2 epsilon naught. You have to remember this or be able to derive it using Gauss's pillbox that cuts it across it. And so you will say, okay, I don't know what E is, but this E and this area A, and on the surface that's area A, and the back is also A. The normal is that way, and normal is out of the box that way. Normal is that way, but the electric field is that way. So on the side, if you do E dot n hat dA of this closed surface, this just gonna give you 2 times E times area, and so amount and this must equal. So Gauss is saying that if you do an integral like this, you will say how much charge is enclosed. So sigma 0 times area and divided by epsilon naught. This is a charge enclosed epsilon naught, and when you equate this, then E just tells you sigma 0 over 2 epsilon naught. So on this side you have electric field like that. On this side is sigma over 2 epsilon naught, like this, from each of the positively charged plate. Now if you happen to be a negative charge plate, then you will have same electric field value, but it's going to be oriented like this. E will be sigma 0 over 2 epsilon naught, and E will also be sigma 0 over 2 epsilon naught. This magnitude, so just keep positive. The direction is in the arrow. Okay, sign in arrow direction, not in the magnitude. All right, so now let's look at A in region 4 of this. So in this region, the magnitude electric field is 0. So let's see this guy. Each one of them, let's start from plus sigma 0 is going to create electric field this way, electric field this way. Everybody's creating same electric magnitude because so all from plate plate 1. So this is plate 1. This line. Don't have to worry about outside. It also create outside over there, but over here it's this way. So now look at the plate 2. Plate 2 is going to be pointed towards the plate 2, 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 towards the plate 2. Plate 3 will away from the plate 3. Away, away, away from the plate 3, away from the plate 3, away from plate 3. And then plate 4 is negative, so all towards it, towards 4. So plate 1, plate 2, plate 3, plate 4 need to do plate 5. Plate 5 positive is going to be away on both sides, away here, away here. 6 is negative, so it's going to be towards it. So now we just have to see how much cancel I have. So let's look at which cancel which. Let's just this cancel that, this cancel that, this cancel that. So it's going to be electric field will be 0. This is correct. So this one is correct. If I go over there, magnitude electric field, now it's about region 3. The magnetic field, the electric field will be this. I don't know. So the 1 changes and 6 changes, right? So 1 will be half as much. So these arrows will be half as much. So let's put these guys over here with a dot. Same thing, but it's going to be dot, 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 dot. But this guy's dot will mean half as much. So this blue and the red combination is for configuration number 2. Okay. If you feel like you're going to get too confused, then it's okay to kind of write it out over here. One more time, just have to copy the whole damn thing. So this will be for 6, will be towards it with a dot. So this dot one has half as much magnitude. And then all of this will be the same. So I'm going, this number 2 will be this way, this way, this way, this way, this way. This for number 2, plate number 2. Plate number 3 will be away from that. Plate number 3 will be away. It's just coming from positive charge, electric field away from the positive charge, and electric fields land on the negative charge. So I'm going to this. So this gonna be towards it. It's easy to get confused when I'm talking, but I'm not talking, probably it should just be Fine. Okay, so now this is about region 3 of the configuration. So we look at region 3. So let's see, some of this just cancel. So this will cancel this, this will cancel this. Then you have half this way and half that way. They cancel. You can see over here, they also cancel. And so this must be incorrect. So this is incorrect. Okay, so let's see if potential difference between the first and the last sheets. Okay, to see is about potential difference now, right? So potential difference, how do you do? Delta V is equal to minus some point A. So like this is difference between these two guys. Electric field dot dl. So you take a A to B path and just go through this this adding up. Okay, so yeah, I'm in configuration 1 and it says first and last sheet. So I start from a point here and go to a point here. So we can go this path in space in that direction and we just pick up. So in this region you have 1, 2, so each one just let's cancel. So this positive cancel, this negative, this positive cancel, this negative, and there is a positive to the right and there is a positive here. There are two positives, right? So for this going to be, and each electric field is sigma 0 over 2 epsilon naught, and this dl is, let's just call it a little d. So it's come from here to here. In 2 I have to go, let's see, this cancels this, this cancels this, this cancels this. So I got a 0 in the second, and third one, this cancel this, this cancel this, but this is positive. So it's actually one more of these guys, 2 times sigma 0 over 2 epsilon naught. Okay, times d. So region 1, region 2, region 3, region 4 will be is 0, so that's going to be 0. Region 5 will be over here. This cancels this, this cancels this, they add, so it's going to be another one of these guys, 2 times sigma 0 over 2 epsilon naught d. So these 2's, cancels out. So this is equals to 3 sigma 0 over epsilon naught d, and I just have to figure out if it's going to be 5 volt. So 3 times sigma 0 got 9 microcoulomb. So there's a 9 minus 6 microcoulomb per meter square, and epsilon 0 9 times 10 minus 12. 9 times 10 to the minus 12 and D is 10 to the minus 3 in terms of meter. This 9 cancels out, and this whole thing becomes 12 minus 9 is 3, not 5 volt. This is not correct. And this also seems like a bit too high a voltage, but let's see, make sure microcoulomb per meter square, and 10 minus 12 fire. So everything, this is micrometer, not millimeter. So I micrometer 10 minus 6. 3 volt, not 5 volt, not 5 volt. So this is incorrect. First and last sheet of the configuration 2 is 0. So you know how this occurred here. So from that experience, we know just have to figure out which parts are non-zero electric field and just go with this. So this is half, so forget the half first. This guy cancels this guy cancels this, and this cancels that. So this is 0 here. Okay, now this cancels that, but these guys don't cancel. They go to the left, but this guy cancels that guy. So this is in this region. I'm going to pick up, so I'm going to pick up minus 2 times sigma 0 over 2 epsilon naught d in this region, because 0, and then let's see, this one, this is 0, so it's going to be 0. Already know it's cancelled out. This guy cancels this guy, this left cancels right, and this is adds minus 2 sigma 0 over 2 epsilon naught d. This cancels that, this cancels that, this cancels that, plus 0. So you have region 1, 2, 3, 4, 5 all worked out, just like this, doing this integral. Okay, and this is definitely not 0. This didn't cancel out, so I really don't have to check 0 not 0. If numerical other than 0 is given, then I have to work this out and see if the numerical is correct. So this is also incorrect. So interestingly, just this is correct, and you might get a little doubtful about your answer because you think there are 4 choices and there should be more correct. But if you've done it correctly, you know, if in the test, if you feel doubtful, maybe just redo the whole thing. Take another 3 minutes, 5 minutes, 4 minutes. Now that you have figured out the procedure, you should redo this out in case you have any doubts, because this is a problem that you should get 100% mark on. It's just very small amount of information needed from your learning before, and kind of put together. And this integral is very simple, just multiplication, because it's capturing constant values in different parts. As you go from A to a point next to this last plate, same over here, go from A to B, you're capturing small amounts. Okay, and this negative is, you can say I'm going B to A. So you say VB minus VA. It comes from electric field is minus del V. These two are equivalent. Okay, all right. I will stop here. I think this is a good problem to do. I'll see you another problem. Bye.